Hello, and thank you for listening and watching this YouTube presentation for Rolls Battery Engineering. My name is Steve Higgins. My contact information is below. Email address is steve@stret.com. I'm the technical services manager for Rolls. All my material is currently available for download. It's currently stored on a Google Drive. For the link, go ahead and send me an email to steve@stret.com. And I'll see if I can put the link down below also so you can have access to it in the comments section. Today we're going to talk about using SMA product on Rolls batteries. With SMA, there's two main types of system. There's a what's called an AC-coupled, where you're using SMAs connected to grid tie inverters. Those grid tie inverters are connected to basically a string array. And then you're using an AC sunny, an SMA sunny island to basically AC couple the system. There's also the pure off grid, where you only have a SMA inverter or a sunny island inverter, and you've got a DC to DC coupled charge controller. There's a couple of things you've got to keep in mind with these two. We're going to start with the easy one. The easy one's pure off grid. This is a lot like the Outbacks and the Snyders, and basically you have a battery-based inverter that's taking battery power and inverting that battery, taking that DC voltage, inverting it to AC voltage, and then of course using a DC to DC solar charge controller to charge the batteries directly. So again, here's an assumed system. Let's say we've got two 60 amp MPPT controllers. We're just going to leave them nameless at this point in time. I'm not going to show any favorites there, but we've got 16 S550 batteries for 856 amp hour battery bank, and we got a sunny island that's capable of 140 amps of maximum charge current. On that particular product, generally, if you're going to use MPP controllers, like normally, I'm going to set my bulk and absorption voltage and make sure it's temperature compensated from 59.6 to 60 volts. On a 6,000 watt array, I'm going to see an average current of about 100 amps of current, which means it's got a peak of 120, but I'm going to see about an average of 100 amps, maybe even a little bit less. My absorption timers would be 3.59 hours. The inverter though is another situation. So on the inverter, these are the important settings for the SMA inverters. First and foremost, this is a flooded lead acid battery. You need to make sure that you have flooded lead acid battery programmed. If you have it set for gel or AGM, it could change the charging parameter. Make sure it's programmed for the correct battery. Battery charge current maximum, I've got it set for 170 amps. This battery bank at 856 amp hours, it's a flooded lead acid battery bank. The maximum charge rate, amperage wise, that you should submit it to is 20% of the C20 rate. Anything more, you cause damage to the batteries. So make sure that's set to the limit. Absorption time boost, 2 to 2.5 hours ballpark. Basically, there's two different absorption times. There's absorption time boost, and there's absorption time full, okay? And so what absorption time boost and full do is absorption time boost is that's the everyday boost charge. That's the charge that does the battery bank every single day. If your array or your charge sources aren't big enough to get the batteries to a full charge, the batteries are going to sit there and sulfate, and they're going to deficit cycle for a period, okay? Absorption time full is the full amount of absorption time that the battery bank is going to be using. And so it's important to make sure you get these, absorption time boost is supposed to save you on fuel. It's supposed to save you on charge time. It's supposed to keep your batteries cooler. There's a lot of things that it does. What I find more often is customers have their absorption time boost set at 3 or 4 hours when it should be 7 or 8 hours. And they're not getting the batteries up to a high enough state of charge, and so the batteries spend a lot of time in a deficit cycling, and then they fail. Cycle time full. Cycle time full is the amount of time between a boost and a full charge. So if this is set for 7 days, what will happen is on Monday, let's say today's Monday, the 8th of October. Today it completes a full absorption time for this 3 hours. It's going to wait a full week, 7 days before it does it again. Ideally 7 to 10 days. The harder you use the system, the more often you want to get to a full 100% charge time. Ideally, you've got enough of a solar array to get the batteries to a full state of charge within that period of time. Charge voltage boost. Again, this is the voltage and charge voltage full. I've got 2.5 volts per cell. Basically, it's a 12 volt system. That's 15 volts. If it's a 24 volt system, that's 30 volts. It's a 48 volt system. That is 60 volts. What that is for is that tells what these two things do. So charge voltage boost, that's tied to this number. So it's going to take the voltage up to 2.5 volts per cell, 60 volts, and it's going to hold it there for 2 to 2.5 hours. Preferably, I'd like to see 2.5 hours, but a lot of people will set it for this 2 hours. Okay. The same thing with charge voltage full. Charge voltage full, we'll use the absorption time full. It'll take it and hold it there for a full 3 hours, and then it'll go into silent mode or float mode. One of the things I find pretty common that's misprogrammed is the battery temperature. This for flooded batteries needs to be 5 millivolts. For gel batteries needs to be 4 millivolts. I'm sorry, AGM batteries needs to be 4 millivolts, and gels need to be 3 millivolts. If you forget to program those properly, what will happen is that the battery bank will not be properly temperature compensated, and you could see temperature damage to the batteries. You must always install a battery temp sensor. Okay, AC coupled systems. This is not as easy as DC coupled system, because in an AC coupled system, they are designed to sell the power to your grid, or to shave power from, or use the battery to shave power to the grid. If you have a lot of loads running during the day, you're going to take away from the charge capability of the solar. So the solar array should be designed large enough to both sell and charge the batteries. If you don't do so, what's going to happen is your batteries are going to end up in a state of discharge, and you're going to run into problems. The user or the installer is going to have to manually adjust the settings to find the correct settings for their system. This process can take 8 to 12 months to get right. I have clients that have called me that are using AC coupled systems, and it's taken, a year to get their settings tweaked right based on their loads versus how much source they have, and to get the batteries up to that fully charged 1265, 1275 specific gravity periodically. Remember, if you're not getting there and the batteries aren't getting to that full 1265 to 1275 specific gravity, what's happening is your batteries are sulfating, and that sulfation over a long period of time will cause damage to the batteries, regardless of the manufacturer of the batteries. So if we go back to the same system, here are the settings that you need to adjust. Absorption time boost, absorption time full, and cycle time full. These three settings have a direct bearing on how well you're charging, either in a DC coupled system or an AC coupled system. And so the first few months, you need to tweak with those settings to make those settings work properly. So basically, you've got the system all programmed, you're done. Anybody who's watched my webinar has probably seen this slide 100 times. No, you're not done. This is where you go back. You program initially where you think it's going to be, and then you go back and you check. The great thing about flooded batteries is you can go back and you can check specific gravities. If you go back and you check and you look at your specific gravities on this particular system, if we go back and look at the specific gravities in this particular system, we got 228, 225, 230, 235, 230. Basically, all of our specific gravities are all low. What's happening there? Well, what's happening there is you are undercharging your battery bank. And because you are undercharging your battery bank, that's causing the batteries to sulfate. And that continued sulfation at those levels will cause the batteries to prematurely fail. You got to ensure your battery chargers are correct. You need to adjust your settings. what you're probably going to have to do is you're probably going to have to adjust your absorption time boost and your absorption time full settings a little longer. Or if your charge voltage settings aren't correct, 2.45 to 2.5 volts per cell. In this particular case, what we have here is we have 1280, 1290, 1300, 1310, 1290. All these specific gravities are generally just a little bit too high. You don't want to run them too hot. You want an ideal specific gravity of 1265 to 1275. If you run your specific gravities too hot, then what that'll do is you'll burn the battery up. You'll cause the battery to fail early. Again, as I mentioned before in the past, specific gravities are like Goldilocks and the Three Bears. The porridge is too hot. The porridge is just too hot. Too cold. The porridge is just right. You want to get your specific gravities when fully charged to that 1265 to 1275 range. These 1280s, 1290s, and 1300s are a bit high, and so what that's going to cause is that's going to cause an overcharging situation. With this particular system, what you do is you recheck your battery charging settings, make sure that they're correct. You might want to lower your voltage settings. So instead of doing 2.5 volts per cell, drop the charge to 2.48 volts per cell. Shorten the boost charge time. You can shorten the absorption, the full time charge time. You just want to do one. You want to make a small adjustment and then go from there. Wait a couple of weeks and recheck it. Again, it's gonna with a DC coupled system, it's gonna be a lot faster to get that system tuned in versus an AC coupled system where it all depends on the amount of power you're using during the day, and that's going to affect how your battery's charged. So at this point, that there are no more questions. I don't see any questions. If you have any questions directly, please feel free to send me an email. I will be more than happy to respond to your emails. Again, I will put a link to the Google Drive below in the checkbox or the notes section, so you can link to that. If you have any questions, feel free to give me a yell. Steve@threat.com. Thanks for listening. Appreciate it. You have a good day.